In this question, we have AlF3 is sparingly soluble in water. The concentration of its saturated solution is going to be given 6.5 times 10 to the power negative 2. So let's say we have, okay, let's actually look at what we are dealing with first. So we have a sparingly soluble salt, okay, so sparingly soluble salt, so which is going to be AlF3. And okay, when they dissolve in water, okay, we can actually write down AlF3. So earlier they were in solid form, so they are sparingly soluble, so maybe they'll become AlF3 aqueous. Okay, just let's look at it in this way first. So what happens is the concentration of its saturated solution, okay, at 298 is 6.5 times 10 to the power negative 2. So it means that the concentration of AlF3, okay, is going to be 6.5 times 10 negative 2 mole per dm cube. So this is going to tell us that this is going to be the concentration that exists over here. Okay, that is existing over here. So AlF3, which is going to be AlF3 aqueous. So this is going to be the same as we call it as a solubility. Okay, the solubility is also 6.5 times 10 to the power negative 2 because of that. So this one, okay, we know that you can change it into, okay, generally we don't put it as aqueous just like that. So normally we write down AlF3 solid, okay, they will change into Al3 plus 3F minus, okay, aqueous. Okay, this is going to be when we write the, when we want to actually calculate, okay, the solubility product and so on, we express it in this way. So KSP, okay, the solubility product, we just take the Al3 plus and then we take the F minus, okay, and then to the power of 3, and we do not need to take the concentration of the AlF3 because it's going to be solid, okay, which is going to be the constant, so we don't actually include that, okay, in our KSP. So the expression is going to be, you just put the concentration of Al3 plus times the concentration of F minus and then 3 to the power of 3 because of this 3. Now if let's say now if they ask you to calculate, okay, the numerical value, okay, the numerical value, so how to calculate? It's quite simple because the solubility is already, we know the solubility is 6.5 times 10 to the power of negative 2. So we will just use this as our solubility value. Okay, that's going to be AlF3. They will dissolve to give you AlF3, okay, in aqueous form. That's going to be our solubility. But if I want to actually change this, okay, into, let's say, further, okay, if I want to put it AlF3, I want to break it down, so you will get Al3 plus 3 moles of F minus. Okay, so if this is going to be X, we are talking about, okay, 1 mole to 1 mole, so which is also X, and this is going to be 3X, so our X is going to be 6.5. Okay, so what we do is just going to be Al3 plus is going to be X. Okay, so X is going to be 6.5 times 10 negative 2. Okay, that's going to be our concentration of Al3 plus. Where? In this solution, aqueous. And then, okay, F minus, okay, in that solution, okay, I have 3x, okay, 3 times of the solubility, okay, or whatever that we have over here. So that's going to be 3 times 6.5 times 10 negative 2. Okay, and you will have the KSP, okay, if you calculate, you will see it's going to be 4.8, okay, times, don't forget, okay, to the power of 3, yeah, to the power of 3. So it's going to be 3 times, okay, 3 times, okay, the x, so 3 times the x, and don't forget about to the power of 3, to the power of 3 must be included, and you will actually get 4.8 times 10 to the power negative 4. Okay, if they ask you to give the unit, okay, the unit is going to be mole per dm cube. Okay, so to the power of 1 to the power of 3, so to the power of 4. So that will be 4.8 times 10 negative 4 mole to the power of 4 dm negative 12. This will be the answer.